Hello everyone. Today I am going to discuss end semester question paper with question number 1. Distinguish the A part is distinguish between hypothesis driven and data driven paradigms in data science. Provide an example of each. Here we compare two major paradigms used in data science, hypothesis driven and data driven approaches. So first is hypothesis driven approach. This approach starts with a question or assumption first, and then data is collected to test it, and it is a traditional and scientific research. So this starts with a theory or assumption, and data is used to confirm or reject the hypothesis, and the analysis is structured and predictable. So this is the hypothesis driven paradigm. So examples are testing whether online classes improve student performance, checking if exercise reduces blood pressure, and all the aspects are given for the hypothesis driven paradigm and data driven paradigm. Starting point, main goal, approach, data collection, typical techniques, role of domain knowledge, and flexibility. Now the data driven approach, this approach begins directly with data, and patterns are insight merge automatically using models, AIs, or algorithms. So there are no fixed hypotheses at the start in this data driven approach, and no patterns, trends, clusters emerge from data, and these are often used in AI, ML, big data analytics. For example, for data driven are Amazon's system recommending products, Netflix discovering new user viewing segments and detecting fraud from credit card transactions. For this, clustering customers for marketing and predicting traffic patterns using Google Maps. In short, hypothesis driven starts with a question, while data driven starts with the data itself. Now look on to the next part B, which is differentiate between structured, unstructured, quantitative, and categorical data with suitable real world examples. Let's see. In data science, we work with four major types of data. Let's differentiate them in real world examples. Like structured data, it is data organized in rows and columns. These are easily searchable and stored in tables, like example Excel sheets, Excel sales sheet, student marks table, banking transaction records, employee database, and attendance records. Second is unstructured data, where this has no predefined format. It can be text, audio, video, or images. Like example WhatsApp messages, YouTube videos, and photos on Instagram, recorded customer support calls, emails. Third is quantitative data. This refers to numerical value that can be counted or measured. Like example temperature readings, price of products that can be counted or measured, like height of student, number of website visitors, monthly salary. And for this categorical data, these are labels or categories, not numbers, like gender, which is male or female, blood group, AB, B positive, A positive, AB positive, car color, different colors, city name, types of products. These are labels or categories, but not numbers. The This is a classification helps us choose the right tools and models in the data science, because different data types need different processing techniques. All the structured, unstructured data differentiation are given over here. Organization, storage, format, all the aspects are given. Ease of querying, typical analysis, examples are also given over here. And also for the quantitative versus categorical data, all the aspects, all the examples I have explained. Nature of values, main purpose, all the structured, unstructured, categorical, and quantitative data I have explained in this video. Thank you. Hello everyone. Today I am going to explain you the question number 2 from the end semester examination paper. I will explain a simple algorithm that uses Bayes theorem for decision making, which is given in the question number 2. Part A, write a algorithm that uses Bayes theorem for decision making, and the part B, write any suitable algorithm for association rule mining that can print all association rules. And we will also Bayes theorem. We will also discuss about the algorithm that uses Bayes theorem for decision making. So starting on discussing part A. So algorithms is here algorithm can be explained step by step. Step 1, which is define all possible classes or decision. Example spam versus not spam. Step 2, which is for each class, compute the prior probability P, which is class, and this represents what we believe before seeing new data. Now the step 3 is for the observed evidence or calculation, calculate likelihoods P, which is evidence, and class. So example, probability of receiving a message with certain words. Step 4, apply Bayes theorem for each class, that is P class by evidence, which is P evidence by class multiplied by P class divided by P evidence. Step 5th is compute Proster probability for each class, and the step 6 is choose the class with the highest Proster probability, that becomes our final decision, and the 7th is output the decision. So in short, Bayes algorithm updates old knowledge with new evidence to make smarter decisions. All the steps are given over here 1 to 6, and part B is algorithm for association rule mining that prints all association rules. So I will explain a popular algorithm used to generate association rules from transaction data. This is a priori algorithm, so which finds frequent item sets and then forms rules. So first step is the give the input like a transaction data set, minimum support and minimum confidence. So generate, second step will be generate all candidate one item sets. Step 3 is count the support of each item set from the transaction, and the fourth step will be keep only those item set whose support is greater than or equal is less than or equal to minimum support. So these are frequent item sets. Step 5th will be use the frequent item sets to generate larger item sets, 2 item sets, 3 item sets, that's it, by joining previous sets. And on step 6 will be repeat the support counting and filtering until no more item sets can be generated. Step 7 will be for each frequent item set, create association rules from the form A to B and calculate confidence, which is supports A union B divided by support A. So keep only the rules whose confidence is greater than or equal to minimum confidence, and thus lastly output final set of association rules. So a priori rules uses the simple idea that if an item set is frequent, all of its subsets must be also be frequent. So this helps us efficiently generate meaningful rules. So as discussed, part A of Bayes theorem for decision making and part B of association rule mining a priori algorithm. Both the parts of question number 2 are covered in this video. Thank you. Hello everyone. Today I am going to explain the end semester question paper with question number 3. The question number 3 is divided in two parts, A and B. First part is compute mean, median, mode and standard deviation for a given small data set. Explain when each measure is appropriate. So I will explain how to compute mean, median, mode and standard deviation for a small data set and when each one is useful. Let's take a small data set for exam marks 40, 50, 50, 60, 90. So the mean average formula is given over here, x1, x2 to xn, mean summation of n I is equals to I xi divided by n. For a small data set, we will add all values and divide by total count. So it is calculated over here and the total count is 58. The question is when is mean appropriate? So when data is symmetrical, where there is mean appropriate. When there are no outliers, there is mean appropriate, because outliers can pull the mean too much. And then we will look on the median, which is middle values. So sort the data which is already sorted, then middle value which is 50, from left we see 40, 50, middle comes 50, from right we see 90, 60, middle comes 50. So here the middle value is 50, which is the median. So we discuss where median is appropriate. Median is appropriate when the data is skewed and when there are outliers, means median stays stable. Then we see the mode, which is most frequent value. the value occurring with highest frequency. In the data set of given over here, the 50 appears twice, others appear once, so the mode is 50. It is appropriate when useful for categorical or discrete data such as most common blood groups, favorite products, or most frequent grade. Let's look on to the standard deviation, which is spread of data. It measures spread or how far values vary from the mean. So steps are compute mean, find square differences, average them, and take square root. So here by computing the mean, that is 58, finding deviations from the mean, on calculating this 40 minus 58 which is minus 18, 50 minus 58 which is minus 8, 50 minus 58 which is minus 8, 60 minus 58 which is 2, and 90 minus 58 which is 32. Then square the differences, find square differences. So when we squared the deviations, we got 324, 64, 64, 4, 1024. Then variance we calculated, which is sum of all the values divided by 5, which is 1480, divided by 5, which comes 296, and the standard deviation, which is average them and take square root, so it is approx 70.2. So the question comes, when the standard deviation is appropriate. So it is appropriate when we want to understand variability, and it is used in finance, quality control, and risk analysis. So these four measures together give a complete picture: center, typical value, and spread of the data. These are the part B of the question number 3. I will explain the difference between errors and artifacts in data cleaning along with two imputational techniques. So errors in data are the errors are wrong values that occur due to human mistakes, wrong entries, and faulty sensors. For example, age is equals to 240, salary is equals to minus 5,000. These are the errors which are occur due to human mistakes or wrong entries. So these can usually be corrected because they are not systematic. And the artifacts in data are the distortions or patterns created during the data collection or processing. These occur due to sensor noise, data transmission problems, and device limitations. For example, a spike in ECG signal due to movement. Artifacts are systematic and not always correctable. Uh, Also, the difference between is given over here. Basic meaning I've already told, typical causes, how these are caused, examples, artifacts on analysis, and treatment is also given over here. So errors and data which comes errors in data and artifacts in data which comes in the part B of question number 3 is discussed. Now this part in part B, this topic also comes any two imputational techniques. So technique 1 is mean median imputation. Replace missing value the mean or median of that column. And second, work well for numeric data. This mean median imputation which works well for numeric data, and the median is preferred when data has outliers. For example, if height column is missing, fill with mean height. And the second technique is KNN technique, which is K nearest neighbors imputation. So find K most similar rows and replace missing values using the average or majority vote. Then it also works well when data has patterns or correlations. For example, if salary is missing, use values from similar profiles. So in summary, errors are incorrect values and artifacts are distortion, and imputation helps us find missing data to maintain data set quality. So as discussed in this video, question number 3, part A and B both are covered of end semester examination. Thank you. Hello everyone. Today I am going to discuss end semester question paper question number 4, which contains two parts. Part A, explain any 4 common feature engineering techniques for continuous and categorical data. And part B, what is sampling for from a distribution? Describe inverse transform sampling or Monte Carlo sampling with an example. So feature engineering is the process of transforming raw data into meaningful features for machine learning models. Let's discuss 4 common techniques for continuous and categorical data, which is in part A. First is scaling and normalization. So it adjusts numerical data to a common scale. Example 0 to 1 or mean 0, sample deviation 1. and uses helps algorithm like KNN or SVM converge faster. And example, height in centimeter and scale between 0 and 1. This is the first uh, common technique, which is scaling and normalization. Second is log transformation. It applies logarithm to reduce skewness in continuous data. It is used in makes heavy-tailed distribution more symmetric, and example, transforming income data like log income. Third is one-hot encoding, which is which converts categorical variables into binary features. It is used in ML models require numeric input, and for example, color red, blue, green, 100, 010, 001. And the fourth is binding, which is converts continuous variables into categories or bins. It's used in simplified model. It reduces effects of outliers. Now the part B, sampling. Part B of the question number 4, sampling from a distribution and inverse transformation or Monte Carlo sampling. So sampling is a process of selecting data points from a probability distribution to approximate statistics or simulate outcomes. There are two types of sampling: inverse transform sampling and Monte Carlo sampling. In first inverse transform sampling, we compute the cumulative distribution function CDF to the distribution and generate a uniform random number u between 0 and 1, and then find value x such that CDF x is equals to u, then x is a sample from the distribution. Suppose x uh, x and exponential lambda is equals to 1 and CDF is equals to 1 minus exponential minus x. Then we generate u is equals to 0.7 and then solve 1 minus exponent minus x. Then it will come approx 1.2. This is the sampling method of type inverse transform sampling. And then we see the Monte Carlo sampling, in which randomly sample many points from a distribution to estimate expected values or probabilities. It is widely used in simulations. For example, estimate pi using random points in a unit square and count point inside the circle. Pi is equal to 4 into points inside and total points. In short, sampling helps us simulate, approximate, and understand distribution without knowing the full data sets. So in this video, I discussed the question number 4 of end semester, part A and part B both. Thank you. Hello everyone. Today I am going to discuss end semester question number 5. Question number 5 contains part A and B. First part A is distinguish between parametric versus non-parametric models and supervised versus unsupervised learning with examples. So first, let us understand different types of models and learning paradigms in machine learning. First is parametric. So definition of parametric is it assumes a fixed form and a finite number of parameters, but non-parametric is no fixed form but is flexible and can grow with data. For example, parametric, it has linear regression and logistic regression, but in non-parametric, the example is k nearest neighbors and decision trees. In parametric, it has simple it is simple and faster to train, but non-parametric is flexible and captures complex patterns. Non-parametric disadvantages are may underfit if assumptions are wrong, and non-parametric requires more data and it is slower. So parametric models make assumptions about the data, while non-parametric model learns patterns directly from the data. Now let us see the supervised versus unsupervised learning with examples. So supervised data is labeled and unsupervised data is unlabeled. Supervised data, supervised learning goal is to predict output based on input, but unsupervised learning goal is to find hidden patterns or structures. Unsupervised example are predict house prices like regression, spam detection, which comes under classification, unsupervised customer segmentation, which comes under clustering, and PCA. Supervised learning outputs like labels or numerical values, and unsupervised it forms clusters or reduced features. For supervised learning, it is learning like with a teacher, but in unsupervised learning, it is like discovering patterns on your own. After that, part B, which is accuracy, precision, recall, F1 score using a confusion matrix. So now let's define key evaluation matrices using confusion matrices. So the confusion matrix layout is predicted positive and predicted negative on the upper part and the actual positive and actual negative on the left part. So true positives, true negatives, and false negatives, false positives. These are the classification layout. And then matrix definitions according to accuracy. Accuracy is the overall correctness. So accuracy will be TP plus TN by TP plus TN plus FP plus FN. This is the formula for the accuracy. It means overall correctness, and that can be misleading when classes are highly imbalanced. Then precision. Precision is correct positive predictions. Like among all predicted positives, how many are truly positive? Precision formula is TP by TP plus FP. Then we see the recall. Recall is the sensitivity, like means fraction of actual positives captured. Among all actual positives, how many are correctly detected? Formula is TP upon TP plus FN, meaning measures ability to capture positives. High recall means few missed positive cases. Then F1 score, it is the harmonic mean of precision and recall. The formula of F1 is equals to 2 into precision into recall by precision plus recall. It means it balances precision and recall into one single metric, and useful when classes are imbalanced and both false positive and false negative are important. So suppose we have TP is equals to 40, FP is equals to 10, FN is equals to 5, TN is equals to 45. Then accuracy will be 0.85, precision will be 0.8, and recall will be 0.8, and F1 score will be 0.842. It is all calculated from the formulas given over here, and these matrices help us evaluate a model performance, especially in imbalanced data sets where accuracy alone can be misleading. As discussed in this video, end semester paper question number 5, I discussed all both the A and B parts. Thank you.